Good afternoon, everyone. Welcome to GATE training again for day 12. I'm Kanmani SS, Assistant Professor, Department of Civil Engineering, Wastewater College of Engineering. Welcome all the participants, GATE aspirants, to the day 12 session on wastewater management and wastewater treatment by Professor Sharmila A. Professor Sharmila A is an expert in air pollution and wastewater treatment, and she is having an experience of 15 years in Vidyavadara College of Engineering. To share her experience about wastewater treatment, here she is to help you to crack GATE examination. Over to Sharmila ma'am.
Thank you, Professor Kanmani, Madam. Good afternoon, all. I welcome all the GATE aspirants to this session on wastewater engineering, which comes under environment engineering stream. HOD Dr. S.K. Prasad sir, and coordinator Dr. Humesha P.K., and all the organizing committee members for giving me an opportunity to deliver lecture on wastewater treatment. Okay, let me start my session. As I informed you, I'm taking this topic on wastewater engineering, which comes under environment engineering stream, uh, which is session 1 on day 12. So as many of my colleagues has already explained you, so based on the previous question paper analysis for about 27 years, so environment engineering stands at second with 235 marks. And what we can expect in environment engineering stream is it may be questions may be related to water treatment, wastewater treatment, solid waste management, and air pollution. So I'm concentrating on wastewater treatment. So in the wastewater treatment, the syllabus which we have to concentrate will be on a sewerage system design, a quantity of a domestic wastewater. So where we have to concentrate both on quantity as well as the quality of wastewater, that is characteristics of wastewater, and the primary and secondary treatment, effluent discharge standards, then sludge disposal, and the last one is reuse of treated wastewater. So the whole syllabus can be divided into three different streams. That is, one is on collection, the second one is on treatment, a third one is on disposal. So along with these three aspects, even a few concentration has to be given even for the reuse of the treated wastewater. So I'm concentrating today majorly on the collection of the wastewater, and the treatment and disposal aspects will be dealt in the next session on Monday. So first and foremost thing, let us know what exactly is a wastewater. So just to give an definition, so I'll take one example. So we uh, if the water is stored in a tank, and if we allow the water along with the tap, okay. So when we turn on the tap, so the water, before turning on the tap, it is a water, and when it is turned on, it is used for various aspects. So when it is used, it carries many components. So we call that as wastewater. So used water that has been affected by either domestic or industrial or commercial uses, we call that as wastewater, which carries many components. So the composition of all the wastewater usually changes depending on many aspects, like where exactly that water has been used, and how it is used, and how much of the water has been consumed for that purpose. Okay, so normally if we observe the composition of wastewater, it comprises of 99.9% of water, and only 0.1% of it consists of the solid component, which may either be of organic matter, microorganisms, or inorganic compounds. So just to give a brief introduction of that solid component of 0.1, which we are interested to remove with the various treatments. So the same thing, 99% of the water and 0.1% of that solid, which is mainly of, we call that as total solids. Again, these total solids can be of two different types. One is the dissolved solids, the other one is suspended solids. So dissolved solids, so normally, which is very difficult to treat compared to the suspended as well as the soluble solids. Okay, dissolved solids, just to give an example, the dissolved solids, how we can remove with the advanced treatment technology. So for the suspended and the suspended solids, again, it can be of two different types. One is settlable solids and one other one is a non-settlable solids. So normally, depending on the whether the solids comprise of majorly of a non-settlable types or settlable types, the treatment will be finalized. So this is a wastewater which is usually disposed to the water bodies. Okay. So moving on to the first concept, that is sewerage system. So normally in a water treatment, or when we talk about the water, we usually prefer the word distribution. So the water is distributed. Okay, but here, so when the water is utilized for various purpose, whatever the wastewater that is received, we usually we collect that. So that's what we are studying in this particular topic, that is sewerage system. So normally, the principle, fundamental principles of sanitation is to remove all the decomposable matter, or it may be a solid waste, or it may be in the form of liquid or gaseous. So which has to be removed immediately from the dwellings that is near to the house, okay, or residential areas. So it has to be removed in such a way that as far as possible with a faster manner, so that it has to be uh, collected in a safe manner, and it has to be discharged to a suitable places. And also it should not, while doing this, while collecting this, it should not create any nuisance, and disposal should be in such a manner that it does not create any harm to the environment. So disposal, when we speak about disposal, it's not exactly disposing directly to the environment, it is disposing to the treatment plants. So few definitions which is often asked in the various exams. So that is sullage and sewage. So many will be get confused with these two definitions. So let us know what exactly is a sullage and sewage. So sullage is nothing but the waste that is discharged from the wastewater discharged from bathrooms, kitchens, or wash basins, so which does not include even the waste is discharged from similar manner from hospitals or laboratories or operation theaters or slaughterhouse. So it is only the waste water that has been discharged from bathrooms, kitchens, and wash basins. But sewage is which comprise even the sullage water also. So it's a dilute mixture of waste from various other purpose also, even which includes the sullage water as well as the foul discharge from the water closets, urinals, hospitals, tables, etc. So, so when we are collecting a sewage, then it comprises of all the wastewater from the residential purpose or from the industrial areas where it is discharged only from human waste, not the industrial wastewater. But sullage confined only to bathrooms, kitchen, wash basins. And stormwater, which is another component which we have to concentrate in a collection system. That is the surface runoff obtained during and after the rainfall. So where it does not comprise of any sewage water. Okay, stormwater, which is usually carried from the open drains, and if it is nowhere connected with the sewage, then it can be directly discharged without any treatment to the nearby water bodies. Sanitary sewage. So normally the sewage obtained from the residential areas and as well as commercial establishment and industrial establishments. So whatever we usually obtain, that is called as sanitary sewage, and it is usually extremely foul in the nature, and usually it is carried not in open drains. It is usually carried from underground conduits. So, but in case of stormwater, it can be either carried with the open drains or it may be in a closed one. And uh, normally, sewage is a word which is nothing but a domestic wastewater. So, in this particular syllabus, we are concentrating only on the domestic wastewater, which does not include any industrial wastewater. So, it is confined only with the domestic wastewater. So, let us know much about the domestic wastewater. So it is mainly the waste that has been collected from the lavatory basins, urinals, and water closets from, it may be from houses or office or institutions, even from industrial sectors. only from the human waste. That's all, but not the industrial waste which is meant for manufacturing purpose, which has under the water that has been utilized for manufacturing purpose. That will not be included, and it is usually of high foul and which because the reason for that is it consists of a waste discharge from urine or it may be night salt. And normally, if it is not collected immediately, it starts putrefying. That is, and it may also gives a offensive smell. So, and also because as we are aware that because a human waste consists of numerous different types of bacteria, so it start degradation. Okay, it requires a great handling and disposal methods. So industrial wastewater, where consists of spent water, but we are not concentrating or collecting this spent wastewater from industries. But industrial wastewater, which includes human waste, can also be collected and comes under this sewage system. Sewers. So normally, pipes which is carried to collect the wastewater before disposal uh, up to the treatment point, we call that as sewers. And sewerage. So the entire system of collection of the wastewater from different sectors, so which is usually preferred for carrying and disposal of the wastewater, that is called as sewerage. So normally we are concentrating on this sewerage system. So usually the wastewater, which is nothing but the human waste that has been collected either from industry or from a domestic wastewater, it is exclusively called as a dry weather flow. So even sometimes in the question they may ask directly about what is dry weather flow. It is nothing but the domestic wastewater or industrial wastewater, which is exclusively meant for collecting a human waste, and it does not contains any storm water. So dry weather flow, which does not contains any storm water, that is called as dry weather flow. And the method of disposal, anyway, this the different types of methods of disposal will be uh, uh, covered in the next session. So time being, it is of two different types. One is disposal by dilution method to the nearby receiving water bodies, and the next one is land disposal. So if the land is available, so best example for the first one, that is how we dispose with to the receiving water. So best example is Ganga river, and in many of the activities which is carried by the industrial wastewater. So why they have constructed, there are numerous industries on the banks of river, that is only because to discharge the treated effluent which is by dilution method. So if such cases, if there is no availability of the receiving water body, then usually we go for land disposal. Either it may be industrial wastewater or industrial effluent, or it is treated effluent of different methods, which is usually meant for disposal. So next comes what exactly we study in this wastewater engineering or treatment. So this subject usually concentrate more on wastewater. So this topic starts at the point where the wastewater supply engineering ends. So when the water it is used for various purpose, that water will be considered as a wastewater after the utilization of that water. So it can be divided into three different types. One is collection, treatment, and disposal. And in that, we'll study the system of sanitation. So normally it can be broadly classified into conservancy and water carriage system. So here is that the flow chart. It is a sewerage system. So where we can classify that into conservancy and water carriage system. And in the water carrier system, again, it can be broadly classified into three different types. One is separate system, combined system, partially combined system. So conservation system. So what exactly is the meaning of conservation system? So here it is usually preferred in a small towns and villages where the wastewater is collected separately. So that is human excreta is collected separately through the latrines. So it is not, they won't prefer any conduits for the collection of this wastewater discharged from human activities. So here The human excreta is usually collected either in septic tanks or the soap pit. So again, this type of collected waste component after a few years of the design based on the design of a soap pit or a septic tank. So this night soil will be uh, uh, taken out and it is buried. And actually in villages, this after certain period when it is collected and disposed, it is used as a manure. Okay, this is one such system. So where collection of the wastewater is not through the conduits. So that is called as conservancy system. And in the water carrier wastewater is collected through the UGDs, underground under drainage. Okay, this is called this comes under water carrier system. So where water is one of the major media to allow the wastewater, and it can be easily collected at certain points. So here the wastewater discharged from human waste, that is from domestic wastewater, will be easily conveyed to the conduits with the help of water, and it is disposed by taking certain treatment depending on the type of the nature of the wastewater. So depending on that, after treatment, so when it meets the standards, then it can be disposed. So again, disposing of this treated effluent will be of two different types depending on the availability. Whether there is any water system, then it can be allowed to that water system, or if it is there is no water system, then we can allow that for the land on land. So this is the difference what we can observe between the conservancy and water carrier system. So comparatively with the conservation system, water carrier system is the best method. So because even though the cost is very high, so depending on safety, so water carrier system is better compared to the conservancy system. So normally in the water carrier system, one best thing is no human agency is required either in the collection or conveyance or anything else. But in case of conservation system, till today, so we are preferring a human agency to uh, remove that night soil which has been collected either in septic tank or in a soak pits. So, okay, that is also one major drawback of using conservancy system. Again, in a water carrier system, again, it can be classified into three different types. One is separate system, combined system, and partially combined or partially separate system. So in a, just you can observe in this figure, in a separate system, the storm water is collected separately and the human waste is also collected separately. But in a combined system, either it may be a storm water or a human waste, both are collected in one particular system. So that is the difference. Let us know in detail. So in separate system, so we usually lay two different sewers, and the diameter of the sewer is little bit lesser when compared to combined system, because the sanitary waste will be carried in a separate pipelines, and the whatever the water, storm water that is collected in a separate system. So advantages are the size of the sewers are less, and also the load on the treatment unit is very less, because depending on the population, the quantity of the wastewater collected from domestic wastewater is obviously less, because here nowhere the stormwater is combined. And also when the storm water is collected separately, it can be without any treatment, it can be discharged to the nearby water bodies. So the nearby water bodies, it may be a stream or it may be a river, will not get uh, polluted. So that is the major advantage of separate system. And the disadvantage, because actually the water is the storm water is not nowhere connected with the human waste. Sometimes there may be choking of that human waste, because it consists of huge part of solids. So that is one major problem that can be observed in a separate system. And also cleaning of the separate system is quite different. If there is choking in the major pipeline, main pipeline, then obviously extra amount of water is required to clean it. And also it is little bit costlier because it requires two set of sievers. In a combined system of sewerage, so as the figure indicates, both the storm water as well as the wastewater from human waste will be connected to one particular sewer. So usually this type of combined system is usually preferred in the areas where the rainfall is little bit lesser. Okay, advantage. So normally the size is a little bit huge compared to separate system, and choking problem is obviously less, and the cleaning is also very easier. And also it comparison with the cost, it proves to be a little bit economic in a nature compared to the separate system. And also the nuisance which has been created, it is reduced because of dilution from a storm water. And disadvantage here. So majorly in a cities, when the road is little bit not that much wide, then actually this handling of this type of sewers is quite difficult. And also at the time of transportation also it's quite difficult. And load on a treatment plant is obviously increased because when waste or storm water combines with the domestic wastewater, then the whole wastewater with the huge quantity is a burden on a treatment units. So that is the load will be increased. And obviously, as we observed in the previous case, that in a separate system, the storm water which is carried separately can be directly discharged to the nearby water bodies, but here it is not so. So if we it may allow, if we allow that storm water, obviously it may pollute the nearby water bodies. And also one more thing, the pumping of that huge quantity of combined wastewater is obviously leads to difficulty. And the next aspect or third type is partially combined or partially separate system. So normally what we'll observe this, depending on the availability of rain, like sometimes we may combine this to the normal domestic wastewater sewers, and sometimes we may not. So there is an option depending on the availability of rain water or storm water. So advantage, the size of the sewers is not large compared to the combined type, and it is actually advantageous compared to both the either separate or the combined system. So because depending on the availability of the rainwater, it is carried separately, or sometimes even it can be mixed, so that we can avoid silting problem that occurs usually in the sewers. So disadvantage during a dry weather when there is no rain, so the velocity of flow may be low. So we'll come to this aspect about the velocity of flow in the design of sewers. So that is one of the major part or parameter which has to be considered. So while considering this partially combined or partially separate, so we should be very careful about the velocity. So because when we allow the storm water to the domestic wastewater sewers, or when we not, so what velocity has to be maintained. And pumping of the stormwater is necessary, and overloading on the pumps. So because often and often, sometimes it will be mixed and sometimes it is not allowed. Because at that particular time, we should be aware of what is the how exactly it overloads on the pumps. So next, suitable condition for the separate systems. So normally it mainly depends on the rainfall. So when the rainfall is uneven, so we can go for separate system. And when the sanitary sewage has to be pumped, so at that particular time also we can prefer separate sewers. And the drainage area is steep and also allow the runoff quickly. And also the sewers have to be constructed in rocky strata. At that time, large combines will be an expensive. At that time, we can go for separate sewer systems. And for combined, so rainfall, if it is even throughout the year, then we can go for combined systems. And for both the sanitation, sewage, and as well as with the storm water, which has to be pumped. So at that particular time, we can go for combined systems. So it mainly depends on the terrain of that particular area. And also in the area where the sewers is heavily built up and space for laying two types of the pipes is, if it is not available, then we can go for combined. So because for separate system, so whichever the two different types of sewers we are preferring, or pipes we are preferring, it requires lot of space, and effective or quick flow has to be provided. So at that time, so we can go for combined system. So comparison, so depending on many aspects, some many times combined system is very good compared to separate system, but mainly it depends on the rainfall. So availability of rainfall, we have to finalize which system suits to that particular area. So one question which has been asked in the gate in the previous years. So for 1 mark, that is a combined sewer is one which transports. So normally I explained you domestic wastewater, domestic sewage. Here they have specified domestic sewage, combination of domestic sewage with the industrial waste, domestic sewage and overhead flow, domestic sewage, industrial and stormwater. So one thing we have to notice here is, so industrial waste, whether this waste is from human discharge waste or industrial, where it is preferred for the other works. Okay, so but the question answer is domestic sewage and stormwater. So because industrial wastewater, which is preferred for many other purpose, will not be included in the combined sewer. Okay, next comes the quantity. Here we speak about much about the design aspects. The quantity of the sewage is a major component which has to be considered in finalizing whether we prefer for the combined or separate, or partially combined or partially separate. So depending on the quantity of the sewage from that area, and as well as the stormwater that is received. Okay, so some of the factors which has to be kept in mind in determining the quantity, that is design of the sewerage scheme. So as I told you, which type we prefer. So is it separate or combined, or partially separate or combined, and also the size, shape, and depth of sewers. Again, availability of space for allowing this sewers, and size of the pumping unit. So to calculate all this, or to design all this, we the quantity of estimation of the quantity of sewage and stormwater is very important. Estimation, so we have to calculate separately the wastewater discharged from domestic wastewater and the stormwater. So again, if we go for combined, we make use of these two aspects, and also to calculate the separate systems. Sanitary sewage is quantity of sanitary sewage is different, and the stormwater should be taken separately. And as I explained you, sanitary sewage, which consists of only the wastewater discharged from residential areas, which we call as dry weather flow, and stormwaters, only the runoff from the roads, ads, and open spaces during rainfall. So because why I'm explaining this, because we have to separately calculate, and for the combined system, then we have to add these two quantity of wastewater, so that we can design for what should be the diameter of the combined sewer. So one major thing, already you have studied in a water treatment engineering, how to calculate the quantity of water with the help of a population. So again, the same information will also be utilized here to calculate or to estimate the design discharge of a sewage for a particular area. So as you are aware that when the wastewater or the water quantity that is required, if we do know that based on the population, so normally we calculate the quantity of water that is required. So similarly, here also the quantity of sewage generated per day at the end of design period will be calculated with the product of forecasted population at the end of design period multiplied by per capita sewage generation. So in a population forecasting method, we have different methods to forecast. So normally when we design for any system, so approximately will take 15 to 30 years as a design period. So keeping that in mind, So it has to fulfill up to 30 to 40 years, depending on what we are designing. So we have to first forecast a population. Then after forecasting population, so we have to calculate the consumption of water, and based on the consumption of water multiplied by the population forecasting, that is the water demand. So after calculating the water requirement or water demand, then we have to multiply that with the per capita sewage generation. So I'll explain you this concept. So normally, whatever the water that is supplied in terms of quantity in meter cube per second, so that has to be multiplied by the percentage, that is approximately 75 to 80%, which comprise of wastewater. So normally the quantity of water supplied is will be very huge, so will be high compared to the wastewater generated. So to the water quantity that has calculated, multiplied by 80% will get the quantity of wastewater. So the same information will be utilized here to calculate the quantity of water wastewater generated per day at the end of design period. So this is one important equation to calculate, because in a few cases in the questions that may be asked, they will directly give the population without giving what is the quantity of wastewater at that time. So we have to multiply to the quantity to the population, what is the amount of rate of water supply, that is LPCD, liters per capita per demand. Normally we usually consider in Indian aspects 135 LPCD and multiply that with 80%, because 80% is nothing but out of the quantity of water that is supplied, 80% will be generated as a wastewater. So that gives the quantity of wastewater generated. So that's what a per capita sewage generation can be considered as 75 to 80% of a per capita water supplied per day. So this is the aspect. Normally when population is directly given without giving a wastewater quantity, we can make use of this data to calculate the quantity of water that will, wastewater that will be generated. And also this may change depending on many factors, like it may be living standards or betterment of economic condition, change the habitat of the people, and enhanced demand from the public utility. So based on all these factors, this there may be variation in the percentage. So normally for Indian condition we prefer 75 to 80%. And other factors, along with this, other factors which we have to take into consideration, as usual I discuss, population is one factor, and the type of area. Whether it's city or metropolitan city or a normal city, and the rate of water supply. So example, 135 LPCD, it may be holds good for rural and semi-urban areas, but for a city area it may be 150 or 175 or 200 LPCD value. So that may change, or that may leads to change in the water quantity. In turn, it changes the quantity of wastewater that is generated and rate of water supply. And the next in is infiltration and exfiltrations. So other than these, some of the other components like habits of the people, number of industries, and water pressure, all this will be taken into consideration. But major factors which we include to calculate the quantity of the sewage flow is the four aspects. Population. So quantity directly depends on the number of population. As it increases, the quantity of sanitary sewage also increases. So keeping this in mind, so based on the population forecasting, so when we design, it may be a laying of a sewers or a treatment unit, treatment plant. So normally we consider for population forecasting for the other 3 or 4 decades, so up to 30 to 40 years. And type of area covered. So whether it is purely of a residential area, or a combination of residential with a commercial area, or industrial sectors. So that has to be considered, because the demand of the water that is supplied will varies depending on the usage. And rate of water supply, rate of sewage is less than the water supply, because as I told you, approximately 75 to 80% of water that is supplied will be considered. And one more major aspect, that is losses due to leakages in the pipes or deductions as a lawn sprinkling manufacturing process, even that is also losses out of the water that has been supplied. So why we are considering 80 to 75 to 80% because of these reasons. And addition to this, surface drainage, groundwater infiltration, and also sometimes the water will be supplied from private wells. So this aspect will also be taken into consideration to calculate the wastewater generated. So next aspect, the fourth aspect is infiltration and exfiltration. So it is nothing but depends mainly on, sometimes there is entry to the sewer pipes, and sometimes there is due to leakage, there is wastewater will flow outside. So that is nothing but infiltration exfiltration concept. So infiltration, if the elevated the sewers elevate is preferred under elevated groundwater, so sometimes there may be chances of entering of this water to the sewer pipelines if it is not maintained properly, so through the joints and exfiltration even through the joints. So there may be chances of losses of this waste. Loss in the sense, because we are calculating quantity of waste generated. So sometimes the expected quantity we may not get at the end point where we want to treat the wastewater. So this exfiltration may be due to the losses, due to the leakages, and also there may be chances of the leakages or overflow from the manholes or chambers or connected surface water pipes. So these two will also be taken into consideration in the calculation of wastewater quantity, so which is entering the treatment plant. And the factors, other factors which we have to, why it happens so in the infiltration or in the exfiltration, that is because of poor construction and pipe joint fittings, root penetration, corrosion, soil condition, and traffic load, as well as aggressive groundwater. So depending on the availability of the groundwater. So design period, as I already told you that normally when we start construction of a treatment plant, wastewater treatment plant, and it may be a laying of pipelines or the sewer lines. So it is usually we are concentrating on the scheme that how many period in the future. So we are utilizing the same components. So that is usually called as design period. So design periods mainly depends on the ease and difficulty in expansion and amount of availability of investment and anticipated rate population growth and hydraulic constraints of this system design, life of the material equipment. So in the design period, so all this factor has to be taken into consideration, so because it has to serve for next 30 to 40 years. So it's one example, a few information regarding the design period for different schemes or components. So for laterals less than 15 centimeter diameter, so we can expected for full developments also without barrage of this much years. But for a trunk or main sewers, normally it may serve up to 40 to 50 years, and for treatment units 15 to 20 years, and pumping plant 5 to 10 years. So this is a design period. Keeping that design period for various components, so usually we calculate the cost as well as the other design aspects. So variation. So why there is a variation in the sewage flow? This is not constant. It may vary from day to day and from hour to hour, and even it may vary to season. Okay, and also sometimes even extra additional flow may also be expected. Example, in few places when there is Mysore in Mysore. So normally in the Dasara period of Dasara, we may expect a huge flow. So seasonal variation, because it affects mainly on the climatic changes. That is when there is huge rain. Okay, so or the at the time of dry season, we may expect maximum or less flow. So more water will be used in a summer season. So we expect high so compared to rainy season. And daily on a daily variation, so depending on again on many aspects, like it may be local conditions or how the water is supplied and the habits of the people and customs of the people. So there is variation in a daily and hourly variation. Normally this is very important. It depends mainly on the consumption of water at which particular time. So normally peak hours will be at the morning from 8:30 to 10 o'clock or 11 o'clock, and again at the evening from 6 to 8 o'clock or 9 o'clock. So that is hourly variation. So this one example or picture which depicts the variation of the wastewater flow. So with respect to the water supply. Okay. So when we expect a peak flow, so with respect to our season or hourly variation. So normally the peak will be two different times. One will in the morning and other one will the evening. Okay. So normally the activity of the water requirement is huge. So obviously it directly proportional to the wastewater flow. So for calculating the peak flow, so normally we take 200% of average flow. So when we calculate the average flow, so normally we take for a peak flow 200%. So while designing the sewers or a treatment unit, so always we'll consider this peak flow into consideration. So because it should not be overloaded on a wastewater treatment unit. And minimum flow, so usually whenever we don't expect the activity with respect to the water, so we may expect minimum flow. So during night after 12 o'clock and early morning, so we can expect very less flow of wastewater. So at that time, so normally we consider half of the average. So in the peak flow, so we usually take twice, that is 200% of the average flow, and for the minimum we take half of the average flow. So because this is also an important parameter in the treatment of wastewater. So importance, maximum and minimum flow rates. Why we have to concentrate on the flow rate? So the maximum and minimum flow rate of the sewage, which is the main controlling factor in the design of the sewers. So along with the sewers, even it affects on the wastewater treatment. Okay. So design of sewers. So the main part we are concentrating in this particular section is on the design of sewers. What are the components we should consider? What type of material is to be usually preferred, and what are the shape of sewers usually preferred uh, um, in collection of wastewater? All these things we'll discuss. It is main first thing we have to note or think is we have to estimate what is the sewage quantity. So that is major thing. So already I explained you in the previous slides how to calculate based on the population, how we can calculate the quantity of sewage. The second thing is again the design period. So as I told you, depending on what we are designing, is it a sewer line or is it with respect to the pump, or is it with the treatment units or laying of pumps, laying of sewers? So design period varies. So normally we can take approximately 30 years for the all the types of sewers. And along with that, because as I told you, so there may be chances of infiltration as well as exfiltration. So when the groundwater is very near to the sewage system or pipelines, so even we have to consider even what is the amount of water through the groundwater infiltration occurs. And along with all this, the uh, final thing is we have to even consider where exactly we are laying, what is the workmanship in laying of sewers, and how far it is from a groundwater table, and which materials we are using, and the type of soils. All this has to be taken into consideration in finalizing what type of sewers as well as which materials we are preferring. So all this aspect will be taken in the consideration on the design of sewers. So design criteria. What are the design criteria usually we prefer in the calculation of the quantity of sewage discharge, that is Q value, and the velocity, and all this thing will know. So as I told you in the one of the slide, design of sewers mainly depends on two aspects. One is the discharge, the other one is velocity. So these two are the major parameter which has to be taken into consideration in the design of sewers. So design of sewer is nothing but is not only includes the diameter, even it includes many aspects like whether we are including only the wastewater discharged from human waste, or is it consist of even introducing a storm water also? So that indicates that what type of sewer has to be taken into consideration. So we'll know that in the next slides. So now let us know exactly what are the components we should understand in the design of sewers. So major thing is discharge and velocity. So design period, so normally as I told you, 20 to 30%. And so one major thing which we have to consider, because we came to know what is exactly the sewage, that is 99.9% of water. So we take a specific gravity which is nearly equal to 1. So where the specific gravity of water is also 1. So because 99.9% is almost it's near to water. And velocity, so very important parameter here is velocity. So the velocity should be designed in such a way that it should fulfill both the self-cleansing velocity and limiting velocity. So we'll know what exactly self-cleansing velocity and the limiting velocity. So self-cleansing velocity is nothing but the minimum velocity in which the sewer line should be, the velocity should be maintained within the sewer line, that no suspended solid should be deposited or no choking troubles occurs. So the velocity, so this is a major thing. While explaining the combined and the separate sewers, I told you the velocity is important. So keeping the concept of velocity, sometimes what happens in a separate system, because nowhere the storm water enters, the velocity, if it is very minimum, then a choking problem may occur, and also the solids may deposit. So there is one more problem: if the solid deposit in the sewers, that is what is called as crown corrosion. So that I'll explain later. So, so the minimum velocity what we maintain is very important. So the velocity which should not allow deposition of the suspended solids in the sewers. So usually it is determined by considering the particle size and specific weight of suspended solids in a sewage. Also, we came to know that different types of solids, that is 0.1% of solids, which is usually uh, uh, um, present in the wastewater. So that is very important. So that type of solids, so whether it is settlable solids or it is suspended solids, which type of solids and its size. So depending on that, we have to finalize the minimum velocity. So okay, next other the formulas which is usually preferred in the design of sewers. So one is Chamschild formula, so which is given by V is equal to square root of 8 beta into S minus 1 into G into D by F. So where normally in many of the problems we are not using this formula, but we are some other different formulas to calculate. So let us know that. So minimum velocity. So already explained what exactly is minimum velocity, self-cleansing velocity, where the particles will remain in suspension. It should not allow the particle to settle. And so the criteria what we have to maintain, it should be more than 0.75 meter per second. So in a system, the self-cleaning velocity should be 0.75 meter per second, and not less than that. And there is some information depending on the diameter of the sewers which we are preferring. So the velocity what we have to maintain is a minimum velocity. Example, for a 15 to 25 centimeter diameter sewer, so we have to maintain at least 1 meter per second of the minimum velocity. And maximum velocity, that's nothing but limiting velocity. So this uh, uh, velocity, it's nothing but when the velocity is very huge. So let us take an example of combined sewers. When there is a huge rainfall, the storm water which is allowed directly to the combined sewers. So when the velocity is very huge due to high quantity of wastewater, so at that time, what may happen if the velocity is very huge? So it leads to covering or erosion of the inner surface of the inner layer of the sewers. So even there is restriction for the maximum velocity also. So it may again leads to a major problem. The lifespan of the sewers may decrease if there is corrosion, covering and abrasion between the solid components. So again, even for the limiting velocity, depending on the type of the sewer materials which you prefer, the limiting velocity also varies. For example, for cement concrete, it is 2.5 to 3, so not more than 2.5 to 3 meter per second. So depending again on the type of the sewer materials which we prefer, the limiting velocity, that is maximum velocity should will also vary. And minimum sewer size, not less than 15 centimeter, because it may lead to choking problem. And the recommended size is 20 centimeter, and even in inly places it may be 10 centimeter because of huge slope which is available. And sewer grades, what slope you have to prefer in laying of the pipelines. So in a steeper, no, if it is not steeper, 1 in 20, and slope up to 1 in 40 to 1 in 80 is also preferred for sewers, which is usually preferred for households, which is directly connected to the main sewers, that is public sewer. And gradient for self-cleaning velocity, it should be at least 0.6 meter per second. So for minimum velocity, so at least we have to maintain 0.6, not less than 0.6 meter per second. And also, again, depending on the diameter of the sewers, what should be the gradient we should prefer. So even that should be taken into consideration in before laying a sewers. Next, hydraulic formula. So this is very important. So normally these equations are preferred in the calculation of the problems which will be asked in a GATE or any competitive exams. So these are the equations which we have to remember. So one is the major famous formula, that is Sturgis formula, which is given by V is equal to C into square root of Rs, where V is the velocity of the flow and C is Sturgis constant coefficient, and also R is hydraulic mean depth, S is slope or gradient of the sewers. To calculate this Sturgis constant, we have one equation, that is Kuttel's equation, so which is given by C is equal to 23 plus 0.00155 divided by S plus 1 by N, and whole divided by 1 plus 23 plus 0.00155 divided by S into square root of R into N. So wherein is rugosity coefficient. So normally, even for rugosity coefficient, we have different values. So we have to make use of that uh, roughness coefficient depending on the type of sewers and which materials we are preferring, so that N values varies. And second formula which we usually prefer to calculate the C values, basins formula. C is equal to 157.6 divided by whole divided by 1.81 plus M divided by square root of R. So we know all this. So M is basins coefficient, so which has to be considered depending on the type of sewers which you are preferring. And Hazen-Williams formula to calculate the velocity, 0.849 ch r to the power of 0.63 s to the power of 0.54. So where ch is Hazen-Williams coefficient. And one more thing, using Manning's formula, so which is usually preferred in many of the calculations, V is equal to N 1 by N R to the power of 2 by 3 S to the power of half. And Creams and Birch formula, V is equal to 3.47 R to the power of 2 by 3 S to the power of half. So all this formula we have to memorize, so that this will be the formulas which is usually preferred in a calculation part. And in many of the GATE questions, when we are solving two different uh, uh, problems on this. And Manning's coefficient, as I told you. So depending on the materials which we use, so we have the values. Hydraulic element of sewers. So main thing. So here there is a derivation on this when for the circular sewers. So when it is running full, just observe the figure. So it is a sewer which is running partially full. Okay, for that we have an equation. For normally for a sewer running full, so we have equations. So with the help of these equations, we have to calculate for the circular sewers which is running partially full. So area for circular sewers running full area is calculated by pi d square by 4. So wetted perimeter pi d, hydraulic mean depth, so which is calculated by A by P. And Manning's formula already we came across, V is equal to n by 1 by n r to the power of 2 by 3 s to the power of half, and discharge with the help of if we know A and velocity, area and velocity. And with the help of this, for this figure, to calculate, we have derivations for the circular sewers, which is running partially full. So in the derivation, we make use of few equations for the depth and proportional depth for proportional area. So for proportional depth, that is d by d, so half into 1 minus cos theta by 2. So what this theta is this theta angle made between from the center point of the sewer to the point where exactly the water is touching the sewer inner line of sewer. And proportionate area A by A given by theta by 360 minus sine theta by 2 pi. So this equation is very important because many of the question has been asked based on this equations. And for proportional wetted perimeter, that is P by P, capital P, which is given directly by theta by 360. And for hydraulic mean depth, D by 4 into product of 1 minus 360 sine theta by 2 pi theta. And for proportional hydraulic, this is for sewer with running full. And for proportional hydraulic mean depth for running half, R by R, that is 1 minus 360 sine theta by 2 pi theta. And for proportional velocity, small letter by v, n by n, r to the power r by r, o to the power of 2 by 3. So normally, because we take this value as 1 itself, because it mainly depends on the material. And discharge, proportional discharge given by q by q, theta by 360 into 1 minus 360 sine theta by 2 pi theta whole to the power of 5 by 3. So these equation, that is proportional discharge, proportional velocity, proportional depth, all this equation we should remember so that directly we can make use of this equation in the calculations. So one problem which has been asked in the previous gate question paper. A 20 centimeter diameter sewer is laid at a slope of 0.004 and is designed to carry a discharge at a depth of 10 centimeter with the Manning's coefficient n is equal to 0.014 and a design discharge is. So we have to calculate that what is the design discharge. As I told you, you have to remember this equation for partially running full. So we have an equation d is equal to d by 2, 1 minus cos alpha by 2. So because we don't know what is alpha, we have to calculate this alpha. So after calculation, we'll get alpha is equal to 180. And for area, so we have proportional area equation. So using that equation, so we already calculated what is alpha. So directly we can calculate what is area. And for the discharge, design discharge, one thing we have to notice, we are calculating the design discharge for a partially running full. Q is equal to E into V. And here we don't know what is R. So calculate R by using the formula R by R, 1 minus 360 sine alpha by 2 pi alpha. So after obtaining what is R, so then make use of this equation to calculate what is the design discharge for the sewer running partially full. So we'll get 9.6 liters per second. Okay. This is also for 2 marks. At a peak discharge, the depth of flow and the velocity are respectively. So we have to calculate here. They have given one picture or graph with respect to the partially learning diagram for circular sewer with discharge and velocity, that is V by V and Q by Q with respect to ratio of depth to diameter d by d. So with the help of this figure and with the equations which we already know, so we can calculate. So for calculations, we make use of this equation. Q is equal to A by V, and we know what is A, we know what is V, so we can calculate what is Q. So with the help of Q by Q is equal to 0.4, so we can calculate, or we know what is, we already calculated 0.05 meter cube per second for Q. So we'll calculate what is small q. And from the, with the help of a graph, so d by d, so we have to calculate, just observe here. So we have to calculate what is V by V and what is Q by Q. See, d by d, it's 0.4. with respect to discharge. So with respect to discharge, for the velocity, just observe d by d is 0.4. So then take that from the graph d by d is equal to 0.4 and calculate what is uh, d. And again from the graph, the same thing. So we have to note down what is v by v. So v by v, just observe v by v for 0.4, it is 0.7. So for d by d is 0.4, just observe it is 0.7. So take that value and calculate what is v. So we got 120 millimeter of 0.5, 120 by 0.4 is the second answer is correct. So again, this is with respect to the equations which we derived from partially running full. And one more question. So main trunk sievers larger than 0.9 diameter in diameter designed due to the ventilation consideration of maximum discharge running at, so whether is it which particular full depth. So we usually we consider that as 3 by 4th. So maximum for trunk sievers normally with a diameter of 0.9 meter. So we usually prefer not full depth. It is 3 by 4th. Any sievers, it cannot flow a maximum more than 3 by 4th full. Okay. So construction of sewers. So normally we have different types of sewer materials. So one is asbestos cements, bricks, cast iron, cement, concrete, plain or reinforced, corrugated iron sewers, storeware sewers, steel sewers, plastic sewers, wooden sewers. So these are some of the requirements which is usually preferred for a good sewers. That is, cost should be less, durability should be very good, and it should not be so impervious. Either it should not allow the wastewater to flow or enter inside, and resistance. It should be resistant to corrosion and abrasion also, because when the velocity is very huge, limiting velocity, then it should not, there should not be any abrasion created, and it should not create problem in the inner lines of the sewers. And weight should be a little bit lesser, just for handling and transportation, and strength should be very good. So it can withstand a major load. It may be a major load from on the roads or due to any other external agencies. Types of sewers. So let us know one by one in the fast. So asbestos cements. So normally you can observe. So this type of pipeline, usually the diameter varies, internal diameter varies from 10 to 100 centimeters, and length maximum up to 4 meters. So and here it is easy to assemble, and no labor, skilled labors is required. And here whatever the coupling we usually prefer is ring of coupling or simplex joint. So this is one important question which may be asked in the questions oftenly asked. And usually the pipes, it is resistance to corrosion. This type of asbestos cements, little bit it is withstand corrosion, and also very it has to be transported vertically for transporting of water. And advantages: lightweight, and interior is smooth, and the Manning's formula you can observe is 0.01. And actually it is having an excellent hydraulic efficient sewers. We call this as excellent hydraulic sewers, which fulfills all the parameters. And disadvantages: structurally not very strong, and only when the because of crown corrosion, which I'll discuss. So the because of sulfuric attack, so there may we can expect corrosion only because of that. And brick sewers, so now it is not preferred usually. It is made or constructed within a site, and nowadays even we can obtain replacement of this with the concrete sewers. So because it is now outdated, not much preferred. And the pipes which are plastered from outside to avoid the entry of roots and the groundwater through the joint bricks. So and inside line and with a stoneware or ceramic blocks is usually preferred, because to maintain a smooth so that we can minimize the crown corrosion or corrosion resistance. And next is cast iron sewers. So this compared to the previous two, it is stronger, and actually it can withstand a greater tensile or compressive and bending stresses. And but the thing is, it's costlier. And 100% it's a leak proof sewers, and so that we can avoid either infiltration or exfiltration problem. and less resistance to corrosion. So this major thing, less resistance to corrosion, the major problem what we observe. So and also it is lined just to avoid the resistance. It is lined with a cement concrete or cot or paint or epoxy and joint together by bell or spigot joint and plain concrete cement or reinforced concrete. So diameter available is 0.45 meter and also the reinforced cement concrete is with a maximum diameter 1.8 meter. It is available and it is usually either in situ pipes or precast pipes and this is of better quality and the single cage reinforced for internal pressure is less than zero point 0.8 meter and for double gauge reinforced for both external and inter pressure is more than zero point 0.8 meter. So obviously when compared to the other, so it has a strong it can withstand a strong tension and compression strength and resistance to corrosion and also we can obtain this with any sizes medium with large and disadvantage is majorly with respect to reinforced concrete. So it can corrode with the action of sulfuric acid, where we can observe the crown corrosion problem. And also, it is susceptible to erosion by sewage containing silt or grit. So that is nothing but when limiting velocity is very high, so we can expect this problem. And corrugated iron sewers. This is usually used for carrying a storm sewers, storm water, and protected from corrosion by granulizing or bituminous coating, and made of varying thickness and diameter up to 450 centimeters. So majorly these pipes are usually preferred in household works for the drainage system. So within the residential purpose and size 75 to 315 millimeter for external diameter and usually the inner surface is smooth inner and also it is majorly resistant to corrosion and with respect to weight, lightweight and economical in lining and also joining and maintenance. And the pipe is tough and rigid, easy to fabrication and transportation. High density polyethylene pipes, so not brittle like AC pipes, and hence it causes damage during loading or unloading or handling. So commonly used for conveyance of industrial wastewater. So just observe this. So this question may be asked: high density polyethylene pipes, which is used to convey the industrial wastewater. Steel pipes. So major problem with the steel pipes is corrosion. So we have to take care how to minimize that corrosion. And but it is of lightweight and impervious and also resistance to high pressure. But it cannot withstand a high external load and may collapse when negative pressure is developed. And major problem is corrosion. So because of the anaerobic digestion that exists when there is a uh, there is choking of the waste component. So vitrified clay or stoneware sewers. So this is actually usually preferred in household connections and even for lateral sewers with size 5 to 20 centimeter internal diameter and rarely manufactured with a diameter of 90 centimeters, more than 90 centimeters. And also advantages is resistance to corrosion and strong in compression and durability and economical for smaller diameter rather than for huge diameter. And disadvantages, obviously very huge weight and bulky and brittle, difficult to transport, and it requires a large number of joints as individual pipeline because the length is very small. So next comes shape of the sewers. So shape of the sewers mainly we can consider is circular and non-circular. In a circular sewers, so which is laid below the ground level. So majority of the sewers which we prefer in the wastewater collection is of circular type compared with the other types, and it is easy to construct and handle and no corners. Because of no corners, so the deposition of the waste component when the sewer is flowing less with very less velocity. So deposition of the waste component within the sewers will be less and possess excellent hydraulic property. So with respect to the properties like velocity or any other hydraulic properties, we can expect very good hydraulic properties. Non-circulars, so it is usually preferred for to develop a self-cleansing velocity and also to affect economy in the construction and easy to headway so that it can that a man can easily repair and cleaning. So normally non-circular compared to circular, so for cleaning and repair purpose it is usually preferred. So commonly used is box or rectangular, egg-shaped basket handle sections or horseshoe, parabolic, semicircular, semi-elliptical, U-shaped. So box rectangular sievers, we can observe this in a figure. So it is usually constructed in the olden days, but now we are not preferring this box type or rectangular sievers because the major problem is in the sides, the deposition of the sewer component, that is the solid component will be very huge. And X-shape sievers, so it is having a better hydraulic property and also, but it's costlier, but it is not very much used in many places. That too in India, we are not using it. It's very rarely used. And advantage is slightly higher velocity during the low flow also. So we can expect high velocity. So we came to know what, if there is a minimum velocity, what happens. Basket handle shape sievers. So it as the shape assembles the basket shape, we usually prefer this. We call the name as basket type. So usually it is preferred for combined type of sievers when the flow is full. Horseshoe shape sievers. Its top is semicircular with both with the sides with inclined and vertical, and the bottom is actually flat with the parabolic shape, and the height is more than the width. Okay, and it is usually preferred construction for large sievers with a heavy discharge, such as trunk sievers. Just keep that in mind. For trunk sievers, we may prefer even horseshoe sievers. Parabolic sievers, and so upper arch takes the shape of parabolic. This is the parabolic shape, and also invert of sievers may be flat, and it may be parabolic or elliptical also. I used to dispose relatively small quantity of wastewater or sewage. Semicircular, so a spider area with the bottom, and hence more suitable for construction of a large sewers with a less available head. So with less available head. Now it is replaced by rectangular sewers. Semi-elliptical soft soils. Because there may be chances that there may be damage occurs to the sewers, so it is usually preferred for soft soils and not suitable to carry a large discharges. It is usually preferred for high discharge, adapted for sewers having diameter greater than 180 centimeters or more. U-shape, so trench provided at the bottom, we call as connect, and easy to construct, and also the invert may be flat or semicircular in nature. So this is a major problem what we observe in sewers, that is crown corrosion sewers. So what exactly is a crown corrosion? So when there is the movement is restricted and settlement of the solid particles at the bottom of the sewers, so we can expect uh, anaerobic conditions. So when anaerobic condition occurs, normally the release of H2S gas is very huge. So that H2S gas combines with the oxygen, and also it may leads to the formation of sulfuric acid content, and that may corrode the inner layer in the upper part of the sewers. So major gas that is released here is H2S gas. Okay, so this is occur due to the uh, uh, less movement of the solid particle which settle at the bottom. So when the velocity of the flow is very less, and when we expect very less water flowing, so which will not carry the solid content. So at that particular time, we may expect crown corrosion. So where H2S gas is the major gas which is released in this. So the question has been asked related to this. Ground corrosion in a reinforced concrete sewer is caused by so H2S, CO2, methane, and ammonia. So which one is this? A. Answer is A. So which is asked for 1 mark. And for trunk sewers, one more question for 1 mark. For trunk sewer and outfall sewers, the type of sections usually is preferred in olden days. So which one is that? So already it has been discussed. So it is horseshoe shape. And the most prominent force acting on the underground sewer pipes would be so compressive force. So which it has been explained in all the type of the sewers. And the best sewer material to resist H2S corrosion is it RCC, brick masonry, glazed stoneware, asbestos cement. So RCC, and we expect major corrosion. So it is glazed stoneware. So next part is characteristics of a wastewater. We can classify that into physical, chemical, and biological characteristics. So physical characteristics, so mainly is color, odor, and the temperature as well as turbidity. So turbidity will be usually caused due to the solid component which is under suspension. So the solid parts, 0.01% which comprise of total solids, in that a certain part which is under suspension, so normally colloidal components, so that leads to turbidity of the wastewater. So chemical characteristics, we have many: pH, chloride content, nitrogen content, fat, greases, oils, sulfides, sulfates, and H2S gas. Or it may be a dissolved oxygen, biochemical oxygen demand, chemical oxygen demand. So major part, pH, chloride content, nitrate content, fats, sulfates, all this has been dealt in already in water treatment. So I'll concentrate on the dissolved oxygen, chemical oxygen demand, and biochemical oxygen demand. So chemical characteristics, so normally other than that, general classification is organic component. So it can be classified into organic and inorganic component. So organic component, all the organic components which contains carbon in combination with one or more elements, we call that as organic compounds. So properties are, so usually it is combustible in nature and have low melting and boiling points, and it is less soluble in water, and its molecular weight is very high. And also the organic compound, whatever the carbon content we have in organic compound, this organic compound will serve as a food for the microorganisms. So this is an important component to understand what exactly is a BOD and COD. So classification, so we can classify that as biodegradable and non-biodegradable organic components. So biodegradable, so which acts as a food for the microorganism. So where the complex organic component will be with the help of the bacteria will be reduced to simple one, along with release of carbon dioxide in water. So it is fast and easily oxidized by the organism. So best examples are this is the waste in the waste component, which consists of starch, protein, alcohol, other components, and even animal and human waste. So non-biodegradable organic components, which is difficult and which take a longer time for the biodegradation to occur, and also many times treatment unit, first we have to analyze the characteristics of wastewater. So because of this reason, so because if we want to select the biological treatment methods, then we should be aware of the concentration of biodegradable, non-biodegradable organic components, because which depends mainly on microorganisms. So example is PVC, pesticides, industrial waste, in which it may consist of any other components, cellulose, phenolic component, lactic acid. Next is biochemical oxygen demand. So as the definition indicates, the quantity of oxygen utilized by mixing the population of microorganisms to biologically degrade the organic matter in the wastewater under aerobic condition. So it is nothing but oxygen that is utilized or consumed for degrading a complex organic component to simple one. That is called as oxygen, biochemical oxygen demand. So it's one of the parameter uh, in controlling the pollution. So and also it's an indicator to know whether the wastewater has been polluted or not. Sorry, the water has been polluted or not. So normally we go for testing this BOD. We have a procedure in a lab how we can test it. So just for few information, let me give. So here to analyze the BOD of a wastewater, so normally we go for testing initial DO concentration and a final DO concentration. So that indicates example if you want to analyze wastewater, the BOD of the wastewater. So first at that day we usually analyze for a DO and we call that as initial DOD. And after 5 days of incubation of this wastewater in a BOD incubator, so we'll analyze and whatever the DO we'll get, that we call as a final DO. So that is D2. So normally for a wastewater, we usually go for dilution of this wastewater because the DO presence in the wastewater will be nil or sometimes very low. So depending on the type of wastewater, either we go for strong wastewater or domestic wastewater or treated wastewater, we go for diluting this. So if it is strong wastewater, we take 0.1 percentage of 1.1 percentage of wastewater in a BOD bottle of 300 ml, and the remaining thing will mix with the diluted water. So diluted water is nothing but aerated water, which where we add phosphate buffer, magnesium sulfate, calcium chloride, and ferric chloride, and will aerate for 3 to 4 hours, and that aerated water will be mixed with 0.1 percentage of the wastewater if it is strong wastewater. So either we go for zero point 0.1, zero point 0.5, or 1 percentage. So in terms of 300 ml of BOD bottle, so it is zero point 0.3 or 1.5 or 3 ml of the wastewater in 300 ml of BOD bottle. Remaining BOD bottle will fill with the diluted aerated water. Okay. This is a calculation which is usually preferred in calculating the BOD. So that is D1 minus D2 by P. P is nothing but the dilution factor. If we have preferred a dilution factor, we have to consider that P. And if it is seeded, example, industrial wastewater, if you want to analyze the BOD, then obviously what we'll do, so we'll add a seeding material like a domestic wastewater, which is rich in microorganisms, and then so we'll add that so that we are allowing the wastewater with the industrial wastewater, which doesn't consist of any microorganisms, with introducing the microorganisms so that the biodegradation occurs with a complex to simple one, and that microorganism make use of the dissolved oxygen present in the wastewater, and will analyze the initial DO as well as the final DO after 5 days of incubation. And then we have to consider all this, that is dilution ratio, how much we have diluted, initial DO and final DO, and also the seeding materials has to be considered to calculate the BOD if it is seeded. Okay, related to that, one problem that has been asked in the previous question: the rapid test to indicate the intensity of pollution in a river water. So whether we prefer BOD, DO, or most probable number, that is MTN or total dissolved solids. So normally to calculate to know this, so we go for DO, because to analyze the BOD we require DO of initial day and the fifth day. So the rapid test, what we usually analyze is DO. So anyway, about the DO, I'll explain the DO concept in the next session. So time being, the answer for this is a DO. So DO immediately after collection, we can analyze for the DO using Brinkless method, so that it is the rapid test. But if we analyze for BOD, we have to wait for 5 days. So after 5 days itself, we'll come to know what is the concentration of BO. So in the previous equation, we came to know that. So how we will analyze with the help of this equation. So one more important aspect here, which we have to understand, that how exactly the BOD occurs. So what exactly is how the degradation occurs in a BOD to analyze the BOD. So normally when we analyze for the BOD, we'll not get the reading at that particular day. If we have to wait for 5 days. So what happens in the particular duration? Why we have to analyze for 5 days? So normally 68% of the degradation occurs within the within the 5 days, and remaining percentage of degradation occurs, or biodegradability occurs after 5 days up to 20 days. So we can expect 90% degradation after 5 days up to 20 days, and even after 20 days we cannot expect 100% degradation. So what happens in this? Just observing the figure, we can understand here the fifth day BOD, the biodegradation is only up to 68% or 70%. So at that particular period, so we can observe only carbonaceous BOD, the degradation will be with respect to the carbonaceous component, that is oxidation of organic matter. So after certain days, after 5 days or more than 5 days, and the whatever the degradation that occurs is because of the ammonia presence in the waste component. So we call that as nitrogenous BOD. So in the starting 5 days, why we are preferring the BOD only for 5 days? The reason for that is degradation, that is consumption of oxygen by the microorganism for to degrade complex organic matter to simple one. It's only 68%. So if we wait for further days, even the degradation rate is little bit slower than the first 5 days. So normally we usually prefer a 5-day BOD for analysis. So the remaining thing, I'll explain that in the next session. So uh, with the help of the COD concentration and DO, and self purification capacity and the treatment. Okay. So as of now, what we have dealt in this particular session is, so I explained related to sewerage system, so which comprises of different types: conservancy and water carrier system, and in the water carrier system, separate, combined, and partially separate or partially separate systems, and design of sewers, where we came across how what are the equations that we have to prefer in the calculation when it is running half, and the types of sewers and the shape of sewers. So that all these things, and in the characteristics of wastewater, explained about the BOD. So in the next session, I'll concentrate on the COD and the DO concentration and self purification capacity of of the water, as well as the treatment of treatment units with reuse. Okay, thank you.
Thank you, madam. Uh, I thank all the participants for their patient listening. I request all the participants to give their feedback, which is already posted in the YouTube link and as well as in the chat box. Finally, we need this the feedback. I thank Professor Sharmila ma'am for her. I thank Professor Sharmila ma'am for her giving the. I thank Professor Sharmila ma'am for her detailed study or detailed sharing detailed experience about wastewater treatment plant, about up to BOD, and remaining she will explain us in our next session. Sharmila ma'am. I thank all the participants for their active participation and patient listening. I request you to fill the feedback form that is posted on the YouTube link as well as your chat box. I, I once again request all the participants to join us just after 15 minutes for day 12, session 2 on geomatics